Hello, today we're going to learn how to find gradient of different lines. For example, when you look at this graph of ours, which has distance on the y-axis, and this distance is in kilometers, then time on the x-axis, which is in minutes, it has lines OA, AB, BC, CD, and DE. So how can we find gradients of these lines? And what do the gradients of these lines mean? Let's start with gradient of OA. If you want to find the gradient of line OA, I would advise you to always try to draw a triangle, a right-angled triangle on OA. So you will come at A, you can draw a line that moves all the way up to the end of the line, because the line can start from here and end from here. So we move vertically downwards, and then when we reach where the line stops, we now connect this part like this, and we make sure this is a right-angled triangle. So why do we draw the triangle? The triangle helps us to find the rise, of which the rise is always on the y-axis, and also the run, which is always on the x-axis. So we know that gradient will always equal to the rise divided by the run. And in this case, our rise moves from 0 up to 10. So our rise will be 10. That is for line OA. And our run will be from 0 up to 10. So it will be 10 minutes. So our rise is 10 kilometers and our run is 10 minutes. So this can be written as kilometers, and then this can be written as minutes. So we have 10 kilometers divided by 10 minutes. Finally, what do you think we get? We will get the gradient of OA. This is gradient of OA. We'll get the gradient of OA. 10 divided by 10 will be 1 kilometer per minute. So we are going to use this symbol to mean per, meaning this graph here represents 1 kilometer is always covered in every minute. So this is like the speed. 1 kilometer is covered every minute. 1 kilometer per minute. That is gradient of OA. If we want gradient of AB, you realize that line AB is a horizontal line and we cannot get its rise. So if we want the gradient here, you realize that we will say that gradient is equal to our rise is 0, our run will be from here up to here, and from here we are moving from 10 up to 30. The difference between 10 and 30 is 20 minutes. So we shall get 30 minus 10 and we shall get 20 minutes. So we have gradient of this line AB equal to 0 kilometers per minute. So you can write it as the gradient of AB, this is for AB. So the gradient of AB is 0 kilometers per minute. So what does this mean? It means that along AB there was no distance covered. Then we can find the gradient of BC. Now the gradient of BC, as I told you, you always need to draw a right-angled triangle. So our triangle on BC will look like this. Now here you make sure this is an angle of 90. Now you will need to calculate the rise, which is from here up to here, and you will need to calculate the run, which is from here up to here. So our rise is from this point here up to this point here. Our rise will be 10 minus 5. So our rise will be 5. Our run will be this minus this. This is 35 minus 30, and this will also be 5. There is one thing that you will need to note, that when a graph is moving like this, it has positive gradient. Then when it is moving like this, then it has negative gradient. The negative gradient is brought about with the reduction in y, because you see it is moving from a bigger y value and it is going to a lower y value. So it is a negative. So here our 5 will become a negative, and we will use it as a negative because we are moving from a bigger value to a lower value. Now we are going to say that our gradient for line BC is going to equal to our rise, which is negative 5. We divide it by the run, which is 5, and we shall get negative 1. So the gradient here, the gradient of BC is negative 1 kilometer per minute. So we can write it as the gradient of BC is equal to negative 1 kilometer per minute. Then for gradient of CD, you obviously see that line CD is the same as AB. So CD's gradient will obviously be 0 kilometers per minute. Then for line DE, we will have to draw a triangle on line DE, and the triangle will appear like this. Then we can use this triangle to get our rise and run. The rise moves from here and goes up all the way up to here. So you check from here up to here, we have from 0 up to 5. So this will be 5, and it will be a negative because the line is moving this way. And our run is going to be from 50 up to 65. If one box represents 5, and then that means this line, if it goes up to E, then this is 65. We have 15. So we shall have negative 5 divided by 15, and our gradient will be negative 5 out of 15, which will be negative 1 out of 3, because 5 goes into 15 3 times, and it's a negative because it is going this way. So the gradient of DE will be negative 1 out of 3 kilometers per minute.